Hey everyone, and welcome to This Explainer. Today, we are taking a second look at a world that, honestly, for a very long time was treated like the ultimate ugly duckling of the solar system. We're talking about Callisto. Sitting way out in the dark as Jupiter's outermost major moon, Callisto was pretty much ignored by scientists. They thought it was just this boring, completely unremarkable object orbiting the gas giant. But as we're going to see, this ancient, heavily scarred world is actually hiding one of the most profound, literally game-changing mysteries in our entire cosmic neighborhood.
You know, for decades, the scientific consensus was basically summed up by a single quote: a boring, ugly duckling moon and a hunk of rock and ice. That's really what they thought. Back in the 1970s, astronomers fully expected outer solar system moons to just be dead, uninteresting space rubble. And Callisto? Well, it fit that stereotype perfectly. The early probes zipped by and essentially dismissed it. No spewing volcanoes, no shifting tectonic plates, zero internal heat. It had absolutely no pulse, just a cold, dead rock floating in the dark. But okay, let's dive into this, because a dramatic, landmark discovery in 2025 completely flipped everything we thought we knew about this moon. We went from looking at a supposedly dead rock to asking a staggering, almost unbelievable question. Could the solar system's most dead world actually possess the key ingredients to be a haven for life? It's a massive paradigm shift, and it's forcing us to totally rethink exactly where we should be looking for biology in the universe.
To really understand how we got here, we need to trace the story of how we've studied this moon over time. Ever since it was independently discovered back in 1610 by Galileo Galilei and Simon Marius, and by the way, Callisto is huge, almost the exact size of the planet Mercury, it has very slowly teased its secrets as our tech got better. We started with Galileo's primitive spyglass. Then we got those first blurry close-up shots from the Voyager flybys in 1979. Fast forward to the late 90s, the Galileo spacecraft gathered some incredibly complex data. And finally, in 2025, scientists fed all that old data into modern supercomputers for an advanced reanalysis. And that breakthrough, it changed absolutely everything.
Now, to understand Callisto's true nature, we have to look at its orbit. See, Callisto is dynamically isolated. If you look at Jupiter's other major moons, Io, Europa, and Ganymede, they're locked in this intense orbital dance called a mean motion resonance. Basically, it's a giant constant gravitational tug-of-war. Jupiter pulls on them, they pull on each other, and all that stretching and squeezing creates immense internal friction. We call it tidal heating. I mean, Io is literally melting from the inside out because of it. But Callisto? It sits much further out. It doesn't play in that gravitational game, meaning it gets absolutely zero tidal heating from Jupiter.
Because it entirely lacks that internal heat to melt ice or shift tectonic plates, Callisto's surface is essentially frozen in time. In fact, its surface has sat there practically undisturbed for roughly 4 billion years. Just to put that staggering number into perspective, 4 billion years means Callisto has been sitting there in the dark since before life even began to form here on Earth. It is a true, untouched cosmic relic.
This incredible stability is exactly what makes Callisto the ultimate geological time capsule. It preserves the violent primordial conditions of the early solar system. Because nothing ever paves over the surface, it's the most heavily cratered object we know of. Any new crater just erases an older one. The whole landscape is dominated by these massive multi-ring impact basins, like the 1,800-kilometer Valhalla and the 1,600-kilometer Asgard. It's also covered in what we call cottonnae. These are long, linear chains of craters left behind by comets. Just imagine Jupiter's gravity acting like a massive cosmic shredder, tearing a comet to pieces so it hits Callisto like a shotgun blast straight across the ice.
So, if the outside is a 4-billion-year-old tomb, what exactly is hiding on the inside? To essentially X-ray the moon and figure out what lies beneath all those scars, scientists use gravity data from the Galileo probe to measure Callisto's moment of inertia. Now, I know that sounds highly technical, but it's really just a clever physics trick. It measures how mass is distributed based on how a body rotates. It basically tells us if a planet's interior has separated into neat, distinct layers. You know, like Earth, with its dense metal core, rocky mantle, and lighter crust.
Think of it like a spinning ice skater. Their rotation speed changes depending on if their arms are extended out or pulled tightly to their chest. If Callisto was just a completely uniform snowball all the way through, that moment of inertia measurement would be exactly 0.40. If it had a dense, fully separated metal core pulling all the heavy stuff to the center, the number would be way lower. But Callisto's measurement, it came in at 0.3549. That tells us it's only partially differentiated. It never got hot enough inside to fully separate its materials. Instead, it's kind of like a giant cosmic slushy, where rock and ice are still somewhat mixed together deep down in its core.
And actually, this bizarre, incomplete mixing on the inside is matched by some equally weird chemical extremes on the outside. When scientists run spectroscopic analysis on the light bouncing off the moon, they see a severe split between the two hemispheres. As Callisto orbits Jupiter, its leading hemisphere, the side facing forward, kind of like the windshield of a moving car, sweeps up all this radiation and dust. This turns it much darker and enriches it with sulfur dioxide and complex organics. Meanwhile, the trailing hemisphere, the rear bumper, is super bright and packed with carbon dioxide. It's this wild chemical asymmetry that honestly continues to puzzle astronomers today.
But the biggest mystery by far came when the Galileo probe checked Callisto's magnetic pulse. Now, Callisto doesn't generate its own active magnetic field. However, much like how a metal detector beeps when you sweep it over hidden treasure, as Jupiter's incredibly powerful magnetic field washes over the moon, sensors detected a secondary, induced magnetic field fluctuating around Callisto. And the laws of physics are pretty strict here. For that secondary signal to happen, there absolutely must be a highly conductive, global layer hidden inside the moon carrying an electrical current.
But here's the catch. Pure ice and solid rock? Yeah, they do not conduct electricity well at all. So for almost 30 years, a fierce debate raged in the planetary science community. Was this induced field just a trick? Was it just atmospheric interference caused by Callisto's electrically charged upper atmosphere, the ionosphere, messing with the data? Or, and this is the exciting part, was it undeniable proof of a massive, salty liquid ocean sloshing around beneath the ice, conducting that electricity?
Well, in 2025, that 30-year argument was finally put to rest. A really landmark study by Cochrane and a team of researchers took the data from all 8 of the Galileo close flybys and combined it. Using some seriously advanced statistical modeling, they definitively proved that the ionosphere alone simply cannot account for those magnetic signals. It was a massive breakthrough. The final verdict? Callisto absolutely, undeniably hosts a thick, subsurface, salty ocean. No doubt about it.
So how deep are we talking? Current geophysical estimates suggest this massive ocean of liquid water is sitting incredibly deep beneath the icy crust, potentially interacting with a layer of mixed rock and ice at depths of around 155 miles, or 250 kilometers, down. To put that into perspective for you, that is an ocean buried beneath an ice shield as thick as the driving distance from New York City to Baltimore. It is a truly staggering amount of hidden liquid water. And that depth is absolutely fascinating, because wherever rock and liquid water interact, chemistry happens. When you combine a saltwater ocean touching a rocky interior, alongside those surface deposits of carbon dioxide, complex organic compounds, and even trace amounts of molecular oxygen detected in its thin exosphere, well, Callisto suddenly possesses the necessary chemical ingredients. Ingredients that could theoretically support extremophile microbial life. We're talking something much like the life we find right here on Earth, surviving completely in the dark around high-pressure deep-sea hydrothermal vents.
Now, to be clear, it's a very different environment from its flashy neighbor, Europa. Europa is highly active, heavily heated by tides, and it's constantly shifting and resurfacing itself with a relatively thin ice shell over its ocean. Callisto, by contrast, is a quiet, ancient vault. It is completely geologically inactive, insulated by that incredibly thick ice shell under a 4-billion-year-old surface. But, that actually offers a uniquely stable environment. If life does exist here, it has had billions of uninterrupted years in the dark to slowly, steadily evolve, completely free from all those violent tectonic shifts you see on Europa.
Beyond the search for biology, Callisto offers an incredibly practical advantage for humanity's future. Jupiter's intense radiation belts are, frankly, incredibly deadly to both human biology and spacecraft electronics. But because of its distant orbit, Callisto sits safely beyond the worst of that radiation. Because of this, scientists widely consider Callisto to be the absolute best candidate for a future deep space base camp. It could literally act as the ultimate forward operating base, or a cosmic gas station if you will, allowing us to explore the rest of the Jovian system and the outer solar system safely. But of course, despite this massive breakthrough confirming the ocean, NASA and scientists around the world still have a really daunting list of unanswered questions. We still don't know exactly how thick the liquid layer actually is. We don't fully understand the physics of how this massive ocean survived freezing solid for billions of years without the tidal heating that keeps moons like Europa warm. And honestly, the true origin of all that dark, organic-rich surface material, that's still hotly debated today.
Thankfully, we won't have to wait generations for answers. We are actually entering a golden age of Callisto discovery. A brand new fleet of spacecraft is flying through space right now. NASA's Europa Clipper launched in 2024, and the European Space Agency's JUICE mission is set to arrive at Jupiter in 2030 to perform high-resolution mapping and deep radar sounding of Callisto's thick ice shell. Plus, China's planned Tianwen-4 mission in the 2030s is also targeting the Jovian system to uncover even more secrets.
So, as we wrap up this explainer, I really want to leave you with this thought. Callisto was ignored for decades. It was brushed off as a boring, battered hunk of rock, and now we know it holds a vast, ancient, salty ocean. If the ultimate cosmic ugly duckling is secretly an ocean-bearing world, what other profound mysteries are hiding right in front of us, just waiting to be discovered in the dark corners of the solar system?